measurement of the electrode potentials. What we will now study is that how we actually measure the standard electrode potentials of the different electrodes. Now I can give you an example. I am explaining this with an example, that now in order to measure the E naught value for zinc electrode, what we have done is we have connected the zinc electrode with, of course, our reference electrode, standard hydrogen electrode. Now how it has been connected, that the zinc electrode has been taken, in this the zinc has been taken in zinc sulfate 1 molar solution, and in the case of SHE we have taken hydrogen gas taken in a glass jar with platinum wire in the 1 molar HCl. Now the platinum wire and the hydrogen zinc rod are connected to each other through a voltmeter, and the two solutions are connected through a salt bridge. Salt bridge, you must know, is basically is a delivery tube which is bent in this U shape. Its ends are plugged with cotton, and in this what we do is agar solution, agar gel is actually there in this. Now in this agar gel what we do is we add the salts like potassium salts, like we have potassium chloride maybe, or we can have potassium sulfate, or we can have potassium nitrate. Now why these salts are taken? Because the ions of these salts are having very high ionic mobility, and the main purpose of the salt bridge is to keep both the sides electrically neutral, the reduction half and the oxidation half. Now what we have done is, when we connect this, what we find is certainly the voltmeter shows some certain voltage output. It shows a voltage output of 0.76 volts. Now, what is actually happening? Which species is getting oxidized and which is getting reduced? See, this is most important to understand. What we have done is, we have not interfered into the basics of this reaction. What we have done is that we have taken zinc in the reduced state as well as zinc in the oxidized state in the form of aqueous solution. We have taken hydrogen in the reduced state and hydrogen ions in the H+ ions in the oxidized state. We have connected these two by wire and these two by salt bridge. And we have left this thing on its own, that they must decide on their own that out of this hydrogen and zinc which is more reactive in terms of losing electrons. So what we came to know, that zinc was found to be more reactive, more easily getting oxidized with respect to the hydrogen. So what we notice is that the zinc gets oxidized and it comes out in the solution in the form of, we can write it by some other color, you can make out, it comes out in the solution in the form of zinc ions, and the electrons are left out as such on this rod. Now we know the electrode where oxidation takes place is called anode. Please don't remember the electrodes by their charges, because charges gets reversed in electrochemical in galvanic cell, and it becomes just the opposite what we have when we are having electrolytic cell. So you need to remember by the definitions, anode is any electrode where oxidation takes place. Zinc was getting oxidized in this case. So since oxidation was taking place in this half, we call this as anode. And since it becomes rich in electron, it is given a sign negative. Electron starts traveling towards this side because there is a potential gradient towards this side. Here two hydrogen ions accept this and gets reduced, and they escape out in the form of what? Hydrogen gas, in the form of bubbles to this. So electrons are traveling from left to right, so the current will flow from right to left, and that is why the deflection of the voltmeter will show the direction of the flow of the current, which will be pointing towards left hand side. Now what we find is, slowly and slowly, therefore H ions concentration will decrease, and therefore, but chloride remains the same. So this side becomes negatively charged, whereas since we have having what? More and more zinc ions coming into the solution, zinc ions concentration will increase, whereas sulfate ions number is same. So this side becomes positively charged. So both of these again develops a concentration gradient. So their charges are neutralized by this salt bridge, which is its main purpose. and this is how the circuit gets completed. So this is how we have determined, and this is the basic of how we measure the electrode potential. Now what is most important to understand in this is, these are the two half reactions which takes place. Now what is most important to remember in this case is, therefore, that the cell potential, or I must not use these words because they must be described properly, so I can write the potential output of the cell was found to be 0.76 volt. Now it is said to be due to the oxidation of zinc electrode. Therefore, oxidation potential of zinc is said to be 0.76 volt. We can write this same oxidation potential of the zinc in another form, like this: E naught oxidation of zinc is 0.76 volt. Or we can write the same thing as zinc changing into zinc ions. This zinc oblique zinc ions are written in subscript, and this indicates it's undergoing oxidation and its value is 0.76 volt. Why whole of the values credit has been given to the zinc? Because already we have assumed the value of the hydrogen electrode to be 0. So whatever the potential output we have got in this measurement of the E naught value of the zinc electrodes, whole has been given a credit to the zinc one, and that is why the oxidation potential of the zinc, or E naught oxidation OXD of the zinc, or E naught Zn oblique Zn2 plus ions given a value of 0.76 volt. So this is how what we have done is, we have connected all possible electrodes with the SHE and we have determined their potentials E naught values. Now one thing is very clear in this, like if some electrode is found to be less reactive in the sense of losing electron than the hydrogen electrode, then it is always the hydrogen electrode which gets oxidized. I can give you the example of a copper electrode. Let us do this copper electrode's E naught value, how it is determined first. Let us see another example to how to determine the E naught values of the different electrodes possible. Let us take an example of finding out the E naught value for the copper electrode. Now as we have done, we know the E naught value of any electrode is determined by connecting it with the reference electrode, which is our reference electrode is, it is the SHE. So what we have done is, we have connected copper electrode with SHE. Then the diagram which is drawn here is showing SHE on the left hand side and the copper electrode is on the right hand side, because as per the IUPAC international systems of representation of the electrodes, always the anode is to be drawn on the left hand side and the cathode on the right hand side. Now in this case, as I have told you, the SHE becomes the anode. What we have done is the same thing we have done, that we have taken reduced state of hydrogen as hydrogen gas, oxidized state of hydrogen as H plus, reduced state of copper as copper metal, oxidized state as Cu2 plus ions. These has been connected with wire, these has been connected with salt bridge, and we have left the system on its own to decide that which is more reactive in the sense of losing electron and which is less. What we came to know that the hydrogen was found to be more reactive in the sense of losing electron and it gets oxidized. So in this case what we find is, it was this hydrogen gas which gets oxidized like this. And so what we find is, this side on this side what is happening is oxidation is taking place, and since oxidation is taking place, this electrode will be called anode. And what is happening is that this hydrogen is losing electron and is coming out in the form of H plus ion in the solution. Electrons are left out on this platinum wire. Electrons moves towards this side. The other side will definitely be called cathode. Since electrons are moving towards this side, it is given a sign positive. The another reason of calling this side as a cathode, because it's the electrode where reduction takes place. So the electrons which reaches here, the copper ions gets attracted towards these electrons, accepts them and gets reduced. So reduction takes place on this half. Therefore this half is called cathode. Now what we know that slowly and slowly the concentration of the copper ions will decrease and that of the sulfate ions remains as such. So this solution becomes negatively charged, whereas more of the H plus ions are coming on this side, its concentration increases, so this solution becomes positively charged. Both sides are kept electrically neutral by the help of the salt bridge, and this is how the circuit gets completed. The voltmeter, the electrons are moving from left to right, the current will be flowing from right to left. Voltmeter shows deflection towards left hand side, and the voltmeter shows a reading of 0.34 volts. It shows a reading of 0.34 volts.